Hi everyone, welcome to the Function Junction, where we make math simple and easy to understand. Today we'll learn how to solve systems of linear equations by graphing. So far in this series, we've worked with one line at a time. We've learned how to graph a line, we've learned how to find its equation. But today we're taking the next step. Instead of working with one line, we're going to work with two. This topic is called a system of linear equations. By the end of this lesson, you'll know how to graph two lines, find where they intersect, and understand what that intersection actually means. So what is a system? A system of equations is simply two or more equations that are considered together. Instead of solving one equation, we're looking for a solution that satisfies both equations at the same time. Think of it this way. Imagine one equation is giving directions to one line. The second equation is giving directions to another line. Our job is to find the point where those two paths cross. Why does the intersection matter? This is one of the biggest ideas in algebra. Every point on the first line makes the first equation true. Every point on the second line makes the second equation true. But there's usually only one point that makes both equations true. That point is called the solution to the system. This isn't just where the lines cross on a graph. It's also the ordered pair that solves both equations. Let's look at our first example. Graph the following lines, y equals x plus 2 and y equals negative x plus 6. Step 1, start with the first equation. What is the slope and y-intercept? By remembering slope-intercept form, we know that slope equals 1 and the y-intercept is equal to 2. Step 2 is to graph the first line. Starting at our y-intercept of 2, we can rise 1 unit and move to the right 1 unit. Step 3, look at the second line. We can see that our slope is negative 1 and our y-intercept is 6. Now we graph the second line. Starting at our y-intercept of 6, we rise negative 1 unit and move to the right 1 unit. Step 5 is to analyze. Based on our graph, we can see they intersect right here. We can read the coordinates on our graph to get an answer of 2, 4. Our last step is to verify. We substitute the point we just found into our first equation. We get 4 equals 2 plus 2, which equals 4. Therefore, our right side equals the left, therefore it's true. Moving on to the second equation, we get 4 equals negative 2 plus 6, which also equals 4, so it's also true. So this point satisfies both our equations. Let's look at another example. Graph the following lines, y equals 2x plus 1 and y equals 2x minus 3. Using the same steps as before, let's start with step 1. Using slope-intercept form, we see that our slope is 2 and our y-intercept is 1. In step 2, we can graph the line by starting at the intercept of 1 and then rising 2 units and moving right 1 unit. For our second line, we can analyze the equation to see that our slope is also 2, but our y-intercept is negative 3. In step 4, we can graph this line by starting at negative 3 and then rising 2 units and moving right 1 unit. Based on our graph, we can see that the lines never meet. These lines have identical slopes, so they're parallel. Since they never intersect, there is no solution. Let's look at our last example. Graph the following lines. Y equals minus 3x plus 5 and y equals minus 3x plus 5. Using the same steps as before, let's start with step 1. Using slope-intercept form, we see that our slope is negative 3 and our y-intercept is 5. In step 2, we can graph the line by starting at the intercept of 5 and then rising negative 3 units and moving right 1 unit. For our second line, we can analyze the equation to see that our slope is also negative 3 and our y-intercept is 5. In step 4, we can graph this line by starting at 5 and then rising negative 3 units and moving right 1 unit. As you can see, there is one line. These equations are actually the same line, meaning every point works. This means we have infinitely many solutions. Let's summarize what we just learned. There are 3 possible answers in graphing systems. When we have one intersection, we have one solution. If both our lines have the same slope, meaning they are parallel lines, we will have no solution. Lastly, if we have the same equation, meaning we have the same line, we have infinitely many solutions. Whenever you solve a system by graphing, always ask yourself, where do both equations have the same solution? Meaning, where do they intersect? Congratulations! We successfully learned how to solve systems of linear equations by graphing. If you like this video, make sure to subscribe. Also, make sure to check out our other videos to continue your function junction journey. See you next time!